Hello and welcome to EFA, that is Engineering for All. In this lecture, we will discuss about the encoders and decoders as the combinational circuits. So let us start with the first part, that is the introduction to these two types of the combinational circuit, that is the encoders and decoders. So when you talk about the encoders, so an encoder is an electronic device which reduces a large number of input lines to a smaller number of the output lines, and a decoder is just the vice versa or the opposite uh, of the encoder. So when we talk about the encoders, why do we need encoding? Now suppose, let us say that we are having in a system, we are having a number of input lines which are coming, and out of those number of input lines, only a few lines are having the data, and rest all the lines are vacant, they are not carrying any data, right? So if such lines are being carried forward towards the receiver side, then there is actually the loss of the bandwidth, and we can also say that the system will be more costly, because in that case we have to lay a larger number of the lines which are not working at that time. So what we have to do is we can convert the information coming from these input lines onto the lesser number of the output lines, and then those lesser number of the output lines, they can carry the data towards the further end. So what is the how can this encoder encode the information and send that information onto the output line? That is the main point over here. You can see that there is a relationship between the number of the input lines and the number of the output lines, right? So let us say that suppose we are having a 2 raised to power n number of the input lines, right? So whatever is there in power, that will be the number of the output lines, and that is actually in the power of 2. So let us say that if we are having x number of the input lines, and out of these input lines, only one of the line is carrying the information, right? Only one of the line is carrying the information, rest all the lines are vacant, they are not carrying any information. Then this line which is carrying the information, that information will be in the form of the bits. Okay, so what we have to do is, when this information is received from one of the input lines, the number of bits which are there, according to that the number of output lines are selected, and all the number of input, all these input bits, right, they are distributed onto those number of the output lines, and then they are forwarded. Now suppose let us say that we are having 4 is to 2, right? So first encoder is 4 is to 2, right? So let us say that there will be 4 number of the input lines, and because 4 can be written as 2 power 2, therefore whatever is there in the power, that number of the output lines will be there in the output side. So now when we talk about this 4 is to 2, or 8 is to 3, or 16 is to 4 type of the encoder, all these other type of the encoders which depend upon the number of the inputs and the output lines, and we'll discuss them in the next slides. So when we talk about the decoders, so what are the decoders? When the information is being sent from one side to the other side through the lesser number of the channels, so those informations, when they are received at the receiver end, they are first of all decoded, right? So these bits which are received from the different number of the input lines, they are clubbed together, and then they are sent to that particular output line which is designated for carrying this information. So in this way we can say that in a decoder we are having n number of the input lines, and there will be 2 raised to power n number of the output lines. So in this way we can say the decoder is just the opposite of the encoder, right? So in this case, in encoder case, right, so the input code is 1 out of the 2 raised power n, and the output code is binary code. Input code is 1 out of the 2 raised power n code, right, and output code is the binary code, right? And when you talk about the decoder, in decoder it will be just the opposite of the encoder. So input code will be the binary code, and the output code will be the 1 out of the 2 raised power n. Okay, so let us see the first example of the encoder. Right, so let us first of all discuss the types of the encoders depending upon the inputs and outputs. So encoders can be 2 is to 1, 4 is to 2, 8 is to 3, 16 is to 4, and so on. Right, so you can see over here there is a relation between the input side and the output side on the in the encoders. So when we talk about this 2 can be written as 2 power 1, right? So whatever is there in the power, that will be taken as the number of the output line. So when we are having the information in 2 is to 1 encoder, right? So if in a single line the information is coming, that information can have only one bit, so that bit can be sent on a single output line. Similarly, when we talk about the 4 is to 2, right? 4 is to 2 encoder is having 4 number of input lines and 2 number of the output lines, and 4 can be written as 2 power 2. So whatever is there in the power, that can be taken as the output. So when we are having this type of the code, right? So the information which is coming through the input lines, they will be having 2 number of bits, and those 2 bits will be distributed onto the 2 number of the output lines. Similarly for 8 is to 3 and 16 is to 4. On the decoder side, we are having just the opposite. Whatever information is coming from the lower number of the input lines, they are clubbed together and then they are sent onto a particular output line. So this can be 1 is to 2, 2 is to 4, 3 is to 8, 4 is to 16, and so on. Okay, so let us discuss about the 4 is to 2 encoder first of all. So let us say that we are having an encoder that is 4 is to 2 encoder, and this encoder is having 4 number of the input lines, and accordingly it will be having 2 number of the output lines. Now let us say that one of the input lines, let us say y1 is having the information. When we are talking about this combination of the input lines, you can see that there can be 4 number of combinations which can be coming at the as the input. One can be either 0 0 or 0 1 or 1 0 or 1 1. Okay, so it means that out of these input lines, right, only one of the input line will be carrying the information at a time. It can be clarified with the help of this truth table. You can see, if suppose you are having y3, y2 and y1 equal to 0, only y0 is having the information, then the information, now this is actually corresponding to y0, and y0 is corresponding to 0 0, right? So the information which has to be sent to the output will be 0 0, that is a1 will be 0 and a0 will also be equal to 0. Now if we are having the information only at y1, right, so y3 will be 0, y2 will be 0, and y0 will be 0. So this 1 corresponds to y1, and 1 can be written in the binary as 0 1. Okay, so this is equal to so correspondingly we have to send the information to the output side as a1 will be equal to 0 and a0 will be equal to 1. Similarly, if we are having y2 is equal to 1 and rest all are equal to 0, therefore this a1 will be equal to 1 and a0 will be equal to 0. And for if you are having y3 equal to 1, rest all equal to 0, then a1 and a0, though both will be having the value is equal to 1 and 1. That is, these will be the bits which will be transferred to the outputs. Okay, so now how can we make the circuit diagram? What is the circuit diagram in between this, right? So in this box, so that can be drawn with the help of the information which is received from this truth table. Now you can see that the output a1, that it depends upon these two values, this one and this one. This, if we take this 0 and 0 are there, right, so they will not be having any effect on the output. So this a1 is affected by this one and this one only. So how from where has this one come? This has come from this y2, and this one has come from y3. Therefore a1 will be a function of y2 and y3, and what will be the function? It will be y2 plus y3. As you can see over here, a1 is equal to y3 plus y2. Okay, so after that we are having a0. So what is the value of a0? A0 depends upon this one and this one, and this one is coming from y1 and this one is coming from y3. Therefore a0 will be function of y1 and y3. Therefore a0 is equal to y3 plus y1. So you can see that we need two OR gates to make a 4:2 encoder. Okay, so two OR gates are there. These two OR gates are there, into which in the first one we are giving y3 and y2 as the inputs, and from here we will be getting the a naught, and from here we are having in this OR gate we are giving y3 and y1, and ultimately we will be having the a naught as the output, and one of the inputs is left, that is y naught, right? So because y naught is not used over here, so that will be a straight line, right? That can be drawn, that need not to be drawn, that will not make any effect on the outputs. Okay, so this is how the 4:2 encoder works, and how the 4:2 encoder can be constructed. Now if in the examination you get a question that you have to draw the 8:3 encoder, right? So the process will be exactly the same. That is, here you will be having 8:3 encoder. Here, on this side you will be having 8 number of the input lines. On this side you will be having 3 number of the output lines. In the truth table you will be having from y7 to y0, right? So from y7, y6, y4, y5, y4, y3, y2, y1, and y0. These all will be the input lines, and your output lines will be a2, a1, and a0, right? So the same pattern has to be followed for making the 8:3 encoder truth table, right? So that will be the diagonal ones that will be coming, right? And each of the output, they will be dependent upon the ones which are coming, right, in their corresponding output lines. Okay, so accordingly you can make the Boolean expressions, and then you can make the circuit. Okay, so I'm not repeating the same, because the concept is the same. You can make it yourself. Similarly, for 16:4 can be made, for 32:5 can be made, right? So any value of the encoder can be taken, and that can be constructed in the similar manner. Okay, so let us move on to the next part, that is the decoders depending upon the inputs and the outputs, right? So you can see over here that there is a decoder, right? And this is just the reverse of the encoder. So we are having 2 number of the input lines and 4 number of output lines. So the bits which are coming over here, that is a1 and a0, they will be arranged onto one of the output lines, right? So they will be either sent to y3 or y2 or y1 or y0. Okay, so there's a enable signal given over here, which is optional. You can give or you cannot give. That completely depends upon you. So this enable signal, if it is high, right, depending upon the program, right? So if it is high, then this will work. If it is low, then it will not work. So you can use it or you cannot use it. That completely depends upon you. Okay, so but the rest of the concept is the same. Now over here you can see that we are having 2 number of input lines, a1 and a0. So first of all we have to make a1 and a0 over here, and we'll be having y3, y2, y1, and y0 as our output lines. So all these output lines, right? So they will be zero only in the don't care conditions of this case, right? So this may be taken, this may not be taken. That depends upon your choice. Okay, so the important table starts from this point, right? So from the second line. Now you can see that if the values of if you are having 2 number of the input lines, right? So there will be 4 number of combinations out of these 2 input lines. So they will be 0 0 0 1 1 0 and 1 1. So if you are having 0 and 0 coming from these input lines, therefore if we convert this into decimal, that will correspond to 0 in decimal, and that will ultimately correspond to y naught. Therefore if you are having 0 and 0 at the input lines, therefore the information will be carried by only y naught. Rest all the output lines will be 0, that is 0 0 0, and 1 will be over here, right? After that we are having 0 1, right? So 0 1 corresponds to 1, therefore y1 will be carrying the information, right? So information coming from here, it will be sent on to the y1 output line, and rest all the output lines will remain 0, that they will not carry any information. If you're having 1 0, right, so then we'll be having the information at y2. If you're having 1 1, the information will go at y3, and rest all will be equal to 0. So if we want to draw the circuit diagram, so in this case we need to see that where these values where the output lines are having the values equal to 1. So let us say that first of all we are having y3. So y3 is having the output equal to 1 at this position, right? And correspondingly this 1 is coming from a1 equal to 1 and a0 equal to 1. Therefore we'll be having y3 equal to a1 dot a naught, right? So you can see over here y3 is equal to a1 dot a naught. Okay, so if we talk about the y2 is having the information only at this condition, right? So this condition is coming because we are having a1 equal to 1 and a naught equal to 0. Therefore will be having y naught equal to a1 into a naught complement, right? So we are having a1 dot a naught complement. So after that we are having y1 is having the information at this condition, so this is corresponding to a1 0 and a naught 1. So therefore we will be having a1 complement a naught. So you can see over here we are having a1 complement and a naught. Then we're having y naught equal to a1 complement and a naught complement according to this condition, right? So ultimately we'll be having these four output expressions for the these will be the four Boolean expressions for the outputs, and accordingly we can make the circuit diagram like this, where in this case you can see the enable is again the optional case. Okay, so this is the circuit diagram we can make with the help of these four Boolean expressions. Okay, so if you talk about the 3 is to 8 decoder, 4 is to 16 decoder, again it can be made with a similar concept, right? So again I will not repeat them. So here you can see that after discussing the types of the encoders and decoders in the form of their number of inputs and outputs, the encoders can further be classified into four other categories. The first one is the priority encoder, second is decimal to binary encoder, third one is your octal to binary encoder, and fourth is hexadecimal to binary encoders. We will discuss all these types of encoders in the next lecture. Okay, so thank you so much for watching this video, and if you like it, please subscribe this channel, like it, and share these videos and the playlist with your friends so that they can be benefited. Thank you so much.